Everybody, my name is Stephanie Berhout. I'm a grower at Qualitree. I've been here just about 2 years, and in that 2 years, I've taken an interest in container media and what it has to offer. So I'm excited to talk to you a little bit about how that might be pertaining to lavender and our experiences with quality control and things of the like over the past year and some goals for 2020. Perfect. So with a name like Qualitree, obviously quality and quality control is key. We bring in our media from a local supplier, Sumas Grow, so they blend everything for us and deliver it to us in bulk. We have a good relationship with them, and part of having that good relationship with them means we're not afraid to reject a load if we have to. If you look in the picture on the top right there, that's supposed to be the same recipe of media, but you can see it's clearly very different. The top bag in that picture had an exceptional amount of perlite in it, and its moisture was drier than Tony's humor. We wanted something a little bit similar to the bottom there, and we didn't get it, so unfortunately we had to reject that load, and having that good relationship with them helps us work through these kind of problems. For all of our incoming loads, we actually take a sample of each one. They're all assigned a QR code. You can see the picture there. But as we get these loads in, we assign them a QR code, and we can scan it and bring up the PO, the sample results from the supplier and any sample results that we take here. And how we want to take that in the future is it would be really great if we could scan that sample of that load and get things like, here's the batch of crops that are in that soil as well, so we can actually link any possible problems back to that batch of soil. But that's my wild dreams right now. We have custom blends that we get from our supplier. We have about 6 different recipes. So it is very integral that we have this good relationship with them, and we are testing everything as it comes in to make sure it's consistent through the year. That being said, we are always trialing with different mixes. A big part of what I get to do here is play with a lot of media, get my hands really dirty. And sometimes it's just 5 trays of different types of media from different suppliers, or our own wild dreams of what if we add this, what if we try that. And even if it's just 5 trays, you can really learn a lot from it. So speaking of lavender, what are we looking for in a lavender container media? Some of the most important things are going to be drainage and air. You can achieve that by adding more coarse materials and perlite. Our mix, we have about 30% coarse bark and 10% perlite. I'm not saying that that's going to be a golden ratio of any sort. We do have our recipes, but they are not perfect. That's where I get to come in and kind of fiddle with them and try to perfect them with input from the whole grow team. And you could have the golden ratio if there ever was one, but the way you're handling your media is ultimately going to impact how it is performing, so we'll touch on that as well. Also, something very important is your nutrient buffering, so having good quality peat. We've been exploring different avenues of peat suppliers and what they can lend in regards to buffering. And we're playing with CEC values, and I'll be talking about CEC shortly. At Qualitree, we have a quality control goal of utilizing weight measurement. What does that mean? You saw the scales outside in the field, and that's more so your water management in the crop itself, but we're talking weight measuring for weight at soil fill. So when you have your soil going into your pot, at a certain moisture level and a certain amount of soil in that pot for that crop, it should weigh X amount of grams. So it's going to be a lot of data taking over the next year, but ultimately our quality control will be much better for it. We're also focusing on evaluating the porosity of our mixes, and I'll get into that as we continue, and exploring measurements of CEC to increase our buffering capacity, and specifically regarding to lavender. So I say CEC, and that stands for cation exchange capacity, and I know if you were in a soil class like I was, when you first hear this, you think, what the heck does that even mean, cation exchange capacity? If you can remember anything about cation exchange capacity, just consider it like your crop's dinner plate. So the bigger the value of that CEC, the bigger the plate, the more it can take from it at any given time. So you're giving it more options. That being said, consider what's going on the plate. So what Wilma has been saying earlier, big impact. A little bit more detail into it. The higher your cation exchange capacity, the higher that value is, the more negative spaces that your cations can attach to. So things like your calcium, your magnesium, your potassium. you have high values of it in peat and clay. Those are the things that we are augmenting and playing with values of in our lavender mix. But there's also high values in vermiculite and other organic matter. For our mix, for our lavender, we add 10 grams per liter of clay. We have been typically using this baked clay. I'll have a picture of it coming up, and it's also in your packages, but it's a little bit gritty, and it hasn't been quite doing the job that we want it to. So we have been playing with this. It's a live clay, so to speak. I invite you to come up and feel the difference between the two after the presentation. It's been lending a lot to more surface area and really increasing that CEC, and we're actually working on submitting samples and wanting to play with different values of these different clays for next year. CEC has influences on media pH, so if you have more calcium attached to these different cation exchange sites, it has a better buffering capacity and is adding hydrogen and driving your pH down. And influences on water holding, so generally if you have a higher CEC, it's indicative of either higher organic matter or higher clay, and with that comes more micropores that can hold on to your water for you. So, you may not be able to see it so well in there, but in your booklets you would. You can see just the different textures between the baked clay and the live clay that we've been playing with. Before I get into porosity, I just wanted to touch base on how we do our EC and pH testing here at Qualitree. We use a 1 to 1.5 method, so we would take 100 milliliters of soil with 150 milliliters of distilled water, make a slurry, and then use the meters like you would see here. We compare it to a 1 to 2 method on the second line of the graph there. We rely on this, this graph, or this table, I should say, to compare against how you might also be doing your soil samples with a probe or with a squeeze or a pour-through method. So if we're doing a 0.5 target in our soil, with a squeeze or a pour-through, you'd be looking more for a 2. Our pH for our lavender is looking for about 5.3 to 5.8. So porosity, this is something that we're really wanting to hone in on for all of our mixes, especially for lavender as well. It likes that drainage. Porosity is referring to not the airspace above your soil, but within it, as well as the ability or the space that can hold the water within your volume of soil. So porosity is referring to the space available for water and air in a given volume of media. So within this full pot, how much air and how much water can I actually get in here? So as I mentioned before, how you handle your media will greatly affect your porosity. If you are overhandling it, if you're driving over it, if you're squishing it into the pot, you're going to be dropping your airspace and increasing your bulk density. So you're going to have more volume of that soil in that pot. So just another example of how if you're at the planting line and you're putting your inputs in and you're really squishing that input in there, you're not going to be doing yourself any favors. So how do we determine this? You can submit it to a lab. You can submit a soil sample to the lab. But how it's handled in transport can really impact what your results are, and it might not be indicative of what's actually going to be available to your plants. So we've been doing some in-house testing, and while it can be variant in accuracy, it's a good tool to see if what you have on hand or what is in your pod is on the right track. You can also get some porosity tests from your supplier as well, but again, if it's showing up in one form and you're breaking it up and putting it in your pot in another way, it's not going to be really indicative of what's available for your plant. So I test it here unpotted and in the pot. I test it unpotted because if I'm not getting the air porosity in my soil as a loose fill, how can I expect it to perform once I squished it into a pot? So I just wanted to go over a method that we've been using to test our porosity. It's pretty much the same whether you're doing unpotted or in the pot. You're going to take a dried volume of soil. So in this case, I've got 500 milliliters here. I've got an example up on the board, and it's also on your sheets. So when we get to the math, you'll have a copy to take home so you don't have to memorize it. So you take a dried sample of your mix. In this case, I've got 500 milliliters. I've got a crack on the bottom, and it's sealed with tape. And you want to slowly add water, and you want to add a known volume of water. So when this stuff is dried, all you have is solids and air. So when you add all that water very slowly, sometimes it could take a day. Just slowly add it all until it's just gleaming at the top. You want to record how much water you've added to this mix. And this is going to be indicative of your total porosity space in here, whether it be for air or for water, because you filled it all with water at this time. So once you've added all the water just till the top is gleaming, you know you've fully saturated this. And in this example, we say we added 340 milliliters. Once we've done this, you're going to pull the tape off of the bottom and let it drip down into the bottom container so you can measure how much drips out. The amount of water that drips out is going to be indicative of how much air is going to be left in that volume of soil, right? So in this case, let's say 98 milliliters dripped out overnight. Then you get to do math, and if you're anything like me, you look at math and your eyes just want to roll into the back of your head. So I've done it all for us here. So for this example, if we're calculating for our total porosity, in this case it would be 68%. Average container media is going to be about 60 to 80%, so it looks like we're right within that parameter here. And how much of that is actually going to be available for air? We take our value of how much water had been dripped out, and in this case we get 19.6%. So this is a very interesting number, and I'll get to that afterwards. If you have 68% porosity and you know that 19.6% of that is going to be for air, you know that remaining is going to be 48.4% water holding capacity. But a word of caution, water holding capacity does not mean it's all available for your plant. The soil will hold on to a good amount of that depending on what you have in there. Like I said, clay has a lot of micropores that can really hold on to that water very tightly, and it doesn't mean it's going to be actively available for your roots. So our result on our air porosity was 19.6%, significant because root dieback and disease may result when air pore space is less than 15 to 20%. This was out of a talk by John Irwin that I went to at Cultivate this year. And desirable air pore space for container nursery production is 20 to 30%. So that mix that I had sampled for those results was one of our old mixes that we had used for this, for one of our Elwoodies. So it's interesting to me that thinking that we might need to reduce the fines that are in that mix and start adding some more coarse materials. And luckily our mix has improved since then. The picture on the right here is Lavender angustifolia. It had a little bit of tuft or root rot this year. We think one of the contributing factors was a very dense mix, so less air in there. The premise for doing the pot fill test is very similar. I'm not going to go step by step, but you're going to be doing the same thing, and instead of doing a test from this, you'll do a test from this. And you'll just plug up the holes on the bottom, saturate it, let it drain, and do your calculation. So I've included all of that for you to take back with the instructions, with the calculations. Made it simple.